Tesla's insane new engine was just revealed by Elon Musk. Tesla, the cars, are crazy, right? But have you ever wondered what makes a Tesla stand out? Its unique design and capabilities are evident both on paper and on the road. But there's one more thing that makes Tesla so special: the engine. Ever wonder what makes a Tesla engine so powerful and fast? We'll cover all of this in today's video, so stay with us till the end. Hey everyone, and welcome to Tesla News, where we bring you the newest and best updates about Tesla and Elon Musk. For daily videos, please consider subscribing to our channel. The fundamental difference between electric cars and gas automobiles is their motor, which is powered by either batteries or an electric motor in most situations. It's crucial to remember that gasoline vehicles contain engines with a multitude of moving parts that can break down over time. Tesla's Model S, on the other hand, has an induction motor that was designed by Nikola Tesla himself, as well as an inverter, transmission, differential, battery pack, and regenerative brakes. When it comes to operation, an electric motor differs from an internal combustion engine in that the latter requires a crankshaft with counterweights to coordinate linear piston motion with rotational motion, a flywheel to even out output, a motor to initiate the start, a battery charger, and a cooling system, among other things. A smaller, lighter, and smaller induction motor, on the other hand, provides a direct rotation motion and produces homogeneous output power in comparison. Tesla's induction motor has a power output of 270 kilowatts and weighs only 31.8 kilos, but an ICE with a power output of 140 kilowatt hours will weigh roughly 180 kilograms. The induction motor was moored to a fixed location, three-phase AC outlet that provides its power as soon as it was invented, and well into the 20th century. As a result of the invention of digital electronics by Silicon Valley in the 1960s, the induction motor was finally freed from its moorings. In the early 1990s, Alan Kansky, a maverick engineer who worked in the early days of electric cars, developed one of the first custom portable inverters, a device that converts the direct current DC in an electric car's battery into the alternating current AC a motor requires in order to run the inverter or motor combustion. The induction motor was moored to a fixed location, three-phase AC outlet that provides its power as soon as it was invented and well into the 20th century. As the result of the invention of digital electronics by Silicon Valley in the 1960s, the induction motor was finally freed from its moorings. In the early 1990s, Alan Kakani, a maverick engineer who worked in the early days of electric vehicles, developed one of the first custom portable inverters, a device that converts the direct current DC in an electric car's battery into the alternating current, or AC, a motor requires in order to run the inverter or motor combustion. Elon Musk's co-founders, Martin Eberhard and Mark Tarpenning, would discover this later in terms of technicality. It is general knowledge that an ICE engine produces usable torque and power only between 2,000 and 4,000 RPMs, necessitating the need of a transmission to connect it to the driving wheels. An induction motor, on the other hand, is nearly equally efficient from 0 RPM to around 18,000 RPM. The Model S uses the same simple signal speed transmission as most EVs. The induction motor's smooth power curve, without interruptions to charging gears, is what makes electric vehicles so appealing. Although electric vehicles have a few components that ICE vehicles do not, such as an inverter that converts the DC current from the battery pack into the three-phase AC required by the motor, the inverter also controls the motor's speed. As a result, induction motors are more energy efficient than permanent magnet motors because they do not require permanent magnets. Rare earth magnets, which are famously expensive to purchase, prone to demagnetization or breaking, and subject to wide price changes, are typically used to make the motor of an electric vehicle spin. The induction motor, on the other hand, uses electromagnets, which are coils of wire enclosing a ferrous metal core that can be switched hundreds of times per second by transistors with mystical-sounding names like the complementary metal oxide field effect transistor MOSFET and the insulated gate bipolar transistor IGBT. As a result, a stronger magnetic field emerges from the stator. The motor's stationary portion causes an opposite magnetic field to rise, surrounding the highly conductive copper rotor during operation. As we all know, when two magnetic fields interact, they pull toward one another. For example, if you place a magnet on your kitchen table and move another magnet with the opposite polarity near it, the magnet you hold will attract the other magnet. In a simpler way, when two opposing magnetic fields collide within a motor of a ludicrous Model S P100D, the car takes off like a rocket. While the induction motor is a brilliant technology, it isn't without flaws, as are other electric vehicles. Because of the nature of how induction motors work, the rotor tends to grow hot at times and can even overheat. As you can see, heat is a big waste of energy in an electric car, and it matters a lot. As a result, induction motors are less efficient at low speeds than other motor designs. Fortunately, a cheaper and more efficient solution has always been available as the alternative. A permanent magnet switching reluctance motor is included with the Model 3. The motor is referred to as a PMSRM, or Permanent Magnet Switching Reluctance Motor, by Tesla. It is a novel form of motor that is extremely difficult to perfect, but Tesla succeeded. Tesla's lead motor design, Konstantinos Lakaris, describes the enhanced motor in this way. So as you know, our Model 3 has a permanent magnet machine. Now this is because, for the specification of the performance and efficiency, the permanent magnet machine better solved our cost minimalization function. It was optimal for the range and performance targets. On the other hand, the Model 3 motor is actually smaller in size than even the smaller front motor of the Model S, yet it performs as well as you would expect it to. According to some owners, their Model 3 is capable of running from 0 to 60 in as little as 4.8 seconds. Obviously, the explanation for this could be due to the 1,000-pound weight loss compared to the previous model. Furthermore, the business believes that using a reluctant motor over other designs will shorten charging times while also enhancing energy efficiency up by 20%. As a result of these technological advancements, the company is avoiding the usage of rare earth magnets in its products. Reluctance motors are starting to find their way into a variety of industrial settings. When we look at the whole picture, Tesla's inventive battery packs is using approximately 7,000 Panasonic cylindrical battery packs that are linked to metallic tubes filled with glycol coolant to enable metallic tubes to snake through the gaps between the cells, keeping the battery cool and extending its lifespan. And thus, the battery packs must be large and heavy. Tesla took full advantage of this by putting the battery pack horizontally. The vehicle has a low center of gravity as a result of this design, which leads to superior handling and reduces the need to cannibalize space for passengers and freight. The engine is one thing, but in the case of vehicles, the software is often overlooked and yet is just as important as the hardware. One thing we can all agree on is that one of the things that makes Tesla such a popular brand is that they provide regular software updates for their vehicles, which they deliver wirelessly at the convenience of their owners. The majority of these updates are free and bring various improvements to the vehicles. One of the most recent upgrades is intended to improve the performance of the Model X's unique but frequently criticized Falcon Wing doors. And since most Teslas are built with all of the necessary hardware for functions, this should be a good thing. So this was all. Add your thoughts in the comments section below. Hit the bell icon and also like, subscribe, and share our channel, and stay with us until our next video. We will see you soon with our next video. So be with us, and go watch our Tesla Model X video on your left to see some positive aspects about it as well. Or you can also watch newly updated Tesla Model 3 2022 on your right, and learn more about the Tesla world. Thank you so much for watching.